So you have to prove either this identity is true or false. 1 plus tan x over 1 plus cotan x equal to 1 minus tan x over cotan x minus 1. See if you can prove this one. Okay, again, we are going to start. It's up to you, which side you want to start with. I'm going to start from the left side. So I'm going to write this guy as 1 plus sine x over cos x divided by 1 plus cos x divided by sine x is equal to. Now, if you take the common denominator, which is cos x, remember, I can multiply 1 by cos x over cos x and the 1 at the bottom by sine x over sine x. So they have the same denominator. So I can write this one as cos x over cos x plus sine x over cos x divided by 1 can be written as sine x over sine x plus cos x over sine x. Okay? Because I want to add these two fractions together. They have to have the common denominator. Otherwise, I can add sine x over cos x and 1. Now, if you look at the denominators, they are the same. So I just add the numerator. I get sine x plus cos x divided by sine x. Cos x, sorry. Divided by, this one is going to give me sine x plus cos x divided by sine x. Now, it's obvious that sine x plus cos x from here is going to cancel out the sine x plus cos x in the denominator. So I'm going to get, if you simplify this one, sine x over cos x. This one goes to the numerator, and this cos x stays in the denominator, which is equal to tan x. Now, this is the case that if you look at here, you end up at tan x, but you have to end up at 1 minus tan x over cotan x minus 1. So now you have to start from a tan x, very simple expression, to get to a fraction like this one. So we better, there is no problem with this one. Start simplifying the right-hand side to see what you get after you simplify the right-hand side. Okay? So I just leave it to you to simplify the right-hand side to see if you can get to tan x. Okay, now let's simplify the right-hand side to see if we end up at tan x that we started from the left one. So the right one I can write as 1 minus tan x is sine x over cos x divided by cos x over sine x, because cotan is cos over sine, minus 1. Again, because I'm dealing with fractions, I have to have a common denominator. 1 is really cos x over cos x. So I can write this guy as cos x over cos x minus sine x over cos x divided by cos x over sine x minus sine x over sine x. Now again, if you look, the denominators are the same, so I can just add and subtract the numerator. So I'm going to get in the numerator cos x minus sine x divided by cos x divided by cos x minus sine x divided by sine x. Now, cos x minus sine x divided by cos x, and then cos x minus sine x over sine x can be written as cos x minus sine x over cos x. Now, division by fraction, you're going to flip the other fraction, and then you multiply. So I write this one as multiply with sine x over cos x minus sine x. Now this one cancels with this one, and you're going to end up with sine x over cos x, which is tan x. And if you remember, the left-hand side was tan x, so we are done. We just proved the identity. Try the next one. 1 over 1 plus cos x plus 1 over 1 minus cos x is equal to negative 2 cosecant squared x. Is it true or false? Okay, to solve this identity, if it is identity, I'm going to start with the left one. So I'm going to find the common denominators. The common denominator between both of them is 1 plus cos x times 1 minus cos x. Now, to have 1 plus cos x, this one, to have this denominator, I have to multiply the numerator and denominator by 1 minus cos x. So this becomes 1 minus cos x. I hope everybody's okay. The second fraction, this one, if I want to have the denominator 1 plus cos x times 1 minus cos x, I have to multiply the numerator and denominator by 1 plus cos x. So 1 times 1 plus cos x gives me 1 plus cos x. Now, I'm going to simplify. Minus cos x and cos x gives me 0. Then I get 2 in the numerator. Now, the denominator is 1 plus cos x times 1 minus cos x. Again, a minus b times a plus b is a squared minus b squared. So I'm going to get 1 squared, which is 1 minus cos x squared. But if you remember the Pythagorean identity again, back to Pythagorean identity. What is 1 minus cos squared x? Sine squared x. Because sine squared plus cos squared is 1. So 1 minus cos squared is sine squared. So I get 2 over sine squared x. But remember, 1 over sine x is cosecant of x. So this becomes 2 cosecant of x squared. Now, if you look at the identity here, it says negative 2, which means that this is not really an identity. The answer is false. Okay? Try the next one. Cos squared x minus sine squared x divided by cos squared x plus sine x cos x is equal to 1 minus tan x. Okay, to solve this identity, what I'm going to do, I'm going to start from the left one and try hopefully to get to the right one. Now, to start from the left one, I'm going to use the difference of squares. So instead of writing cos squared x minus sine squared x, I can write this one as cos x minus sine x times cos x plus sine x. Everybody agrees? Right. Divided by, now the bottom one, cos squared x plus sine x cos x, there is something common here, which is, what is common? Cos x is common between the two terms. So I can take cos x out. I get cos x from the first term plus sine x. Now, cos x plus sine x and cos x plus sine x, they cancel out. I'm going to end up with cos x minus sine x divided by cos x. Now, this is the time that you can separate the numerator. I can write this guy as cos x over cos x minus sine x over cos x. Now, what is cos x over cos x? Is 1. Minus sine x over cos x, 10. So this means that the identity holds.